In this question, you must show detailed reasoning. The diagram shows the curve given parametrically by the equation x is equal to 1 over t squared and y is equal to 1 over t minus 1 over t cubed for t greater than 0. We have to show that dy by dx is t squared minus 3 over 2t. Find the coordinates on the point on the curve at which the tangent to the curve is parallel to the line y minus x is equal to 2. And find the Cartesian equation of the curve, giving our answer in factorized form. Okay, so if x is equal to 1 over t, that means that x is equal to t to the minus 2. If we differentiate that with respect to t, we're going to get minus 2t to the minus 3, which we could write as minus 2 over t cubed. And then we've got y is going to be 1 over t, so it's t to the minus 1 and 1 over t cubed minus 1 over t cubed, so it's going to be minus t to the minus 3. Differentiating that, we're going to get minus t to the minus 2 plus, because the minus times the minus, 3t to the minus 4, which we could write as minus 1 over t squared plus 3 over t to the 4, or 3 over t to the 4 minus 1 over t squared. Now, if we're differentiating, we want to find dy by dx. That's the same as getting dy by dt times dt by dx. Therefore, dy by dx is going to be equal to 3 dy by dx is going to be dy by dt, which is 3 over t4 minus 1 over t squared, times t cubed over minus 2, which is the dt over dx. We need to invert this one. Okay, so writing that out again and expanding, we're going to get minus 3t cubed over 2t squared plus t cubed over 2t squared. So that's, if we work this one out, because this one's positive, this is just going to give me t over 2, and then this one's going to give me 3 over 2t. If we make a common denominator of 2t, it becomes t squared minus 3 over 2t as required. Right, the tangent is parallel to this line 3 minus x is equal to 2. So that if we write that in the form y is equal to mx plus c, that will give us m is equal to 1. So it means we need to put the derivative equal to 1 to find the value of t, and then once we've got the value of t, we can put it back in x and y. So solving this, we take this up here, we're going to get t squared minus 3 is equal to 2t. T squared minus 2t minus 3 is equal to 0. This is an easy quadratic. It's t. It's going to be plus 1 and minus 3. And then t is equal to minus 1. That's not possible because t had to be greater than 0 as stated in the question. So some sort of acknowledgement of that looks good. Or t is equal to 3. Right, so we've got t is 3, we've got x is 1 over t squared, and y is 1 over t minus 1 over t cubed. So when we put 3 in here, we get 1 over 3 squared. That gives the x coordinate as 1/9. And here we get 1/3 minus 1/3 cubed, which is 1/3 minus 1 over 27, which is 8 over 27. So that will give me the coordinates 1/9, comma 8 over 27. And finally, we need to write down the Cartesian coordinates. So if we got x is 1 over t squared, then that means that t squared is 1 over x. As t is positive, t will be equal to 1 over t square root of x. If we now substitute that into y, we're going to get y is equal to 1 over square root of x minus 1 over the square root of x all cubed. And if we keep change flip, so that means the root x goes to the top, so we get root x minus root x cubed, which we could write as x to the half, x to the 3 over 2. Because we've got to factorize it, we could write x to the half, then x to the 3 over 2 we split up as x times x to the half, and then we have a common factor of x to the half, and then we're left with 1 minus x, and then we'll just write that back as a third. So the Cartesian form of the equation is y is equal to square root of x times 1 minus x. So this has been a video to show you how to deal with Cartesian equations written in the form of t, being able to find the coordinates of where a tangent would be, and being able to convert the parametric equation into Cartesian form. I hope you've understood, and I thank you very much for watching.